Graphing a rational function is a multi-step process, so we want to make sure that we find several features of the rational function that are important. So those would be the asymptotes, both vertical and horizontal. We want to go ahead and identify x-intercepts and y-intercepts. And then we can kind of take a look at what all of that information gives us and plug in any additional points that we might need in order to generate an accurate graph. So let's go ahead and start by finding those asymptotes. So we can factor this top part, we can factor out a 3. Now that does not lead us to being able to cancel anything. So this is in lowest terms. So to find our vertical asymptote, we can set the denominator equal to 0 and solve for x. So that gives us x equals 2. So that's our vertical asymptote. The horizontal asymptote, we look at the degrees of the top and bottom. The degree of the top is 1, the degree of the bottom is 1. Since the degrees are equal, the horizontal asymptote is the line y equals the leading coefficient of the top, which is 3, over the leading coefficient of the bottom, which is 1. So we have just y equals 3 for the horizontal asymptote. So if I go ahead and graph those two lines as dashed lines on my grid here, so x equals 2 is a vertical line going down. So we know that the graph of our function is going to get close to this line but not touch it. Y equals 3 here. We know at least toward the ends our graph's going to get close to this. And so now we need some specific points on our graph, and some of those points we want to find are the intercepts. Now the y-intercept is usually the easiest one to find. We find that by plugging in a 0 for x. So if I plug in a 0 for x, we get on the top a negative 3 and on the bottom a negative 2. So we have 3 over 2. So that's 1.5. So we'll go ahead and plot that point there. And our x-intercepts we would find by setting the whole thing equal to 0. Since it's a fraction, the only way that a fraction can be equal to 0 is if the numerator is 0. It doesn't matter what the denominator is, because 0 divided by anything is 0. And if the denominator is 0, then it's actually undefined, and that's how we found our vertical asymptote. So the vertical asymptote, you set the bottom equal to 0. The x-intercepts, we can just set the top equal to 0. Because again, the only way a fraction can be 0 is if the top is 0. So this is going to give us x equals 1 as our x-intercept. So we can go ahead and plot that. So we probably have a pretty good idea, at least kind of on the left side of this asymptote, that our graph is going to be in this bottom left portion. I have those 2 points over there, and knowing that I have those asymptotes that the graph's going to get close to, I could sketch in a pretty good graph there on that left side. Now on the right side of that asymptote, I don't have any points. So we need to go ahead and plug some other numbers into our function to get some other points to plot. So 1 or 2 on either side of each vertical asymptote is a good idea. Again, I've already got 2 points there to the left of the vertical asymptote, so let's just pick a couple to the right. So let's plug in a 3 and a 4. So if we plug a 3 in for x, we're going to get 3 times 3 is 9 minus 3, that's 6 over 1, so 6. And if we plug a 4 in, we're going to get 12 minus 3, that's 9 over 2. That's 4.5, so we have 3, 6, and 4, 4.5. And again, using the asymptotes to guide us, we can go ahead and sketch in our graph. So there's our completed graph of the function f of x.